Hello everyone, my name is Prakhar Srivastava. This is my final project for my computer vision class, and I'll be talking about the SVHN classification using convolutional neural networks. So, firstly, I have to admit I am definitely a newbie to machine learning and convolutional neural networks, especially. And this was my first time using TensorFlow and Keras, so definitely had a great experience and would recommend using this. So, for my workflow, I want to talk about firstly, I went through the different data and the pre-processing of that. I used the 32 by 32 images of single letters, and then I reshaped that and normalized it to be able to use with TensorFlow, and also categorized the labels with the utils Keras library. And then I created a VGG16 somewhat like model using convolutional 2D layers, and I also added that in some pooling layers, which would help stride over the convolutions by 2. And for my optimizer, I used Atom, the adaptive moment estimation, and I just found this to work empirically better over against the RMS prop and SGD. Similarly, empirically, I found the most optimized batch size to be 256 and learning rate to be 0.001. Then after all that, I compared the self-developed model to the VG16 model, both with and without the pre-trained weights, and I used the model weights to predict SVHNs in real-world images. So the model accuracy itself, I found the self-developed model, which I created, the model accuracy be about 75 to 80% for validation and test data. And for the VG16, again, 75 to 80% validation and test accuracy. Now, these numbers I know are lesser than some of the best models that you can find out there. And especially the VG16 model, I expected it to do better. But maybe I wasn't doing the pre-processing right in Keras, or maybe I wasn't using the VG16 model properly in Keras. Or maybe just my parameters are slightly off. I could use more parameterization. I did not put the VG16 model without weights in here because that really had very bad performance for me, about 20% validation test accuracy on that one. So, okay, coming to some real-world results, this is using my self-developed model. So I actually found like most of them were pretty well classified, good classification. I had to manually give in the kind of patches of interest for the model to go figure that out. And over here, there are a couple of misclassifications. Over here, you have a 9 mislabeled as 1, but this is probably because it's at the edge here, and it probably thought this was a 1. And similarly over here, actually, this is 5, which it thinks is a 3. But possibly because of the slant, it might be misclassified. So that was it from me. I tried to keep the real world results as close to possible to like different noise levels, different slants, and different sizes. But yeah, that's it from me. Thank you.